For number one, we're working with the normal curve, and we're going to use the standard normal distribution to find the percent of data that is less than the given z-value. Now, a z-value is based off the distribution's mean and standard deviation. And basically, we can use this table of data to find what percent of data in the entire distribution will be to the left of any given z-value. And for 1.59, I'm just going to click on the table to open it. I'm going to go down to 1.5, and then to get the second decimal, you use the column headers up here. So 1.50 is this first column, 1.51 is the second column, 1.52 is that third column, and so on. So 1.59, I would go all the way out here, and this is the percentage of data that is less than the z-value 1.59. So 0.9441 as the percentage, that's 94.41%. You can also do these in Excel if you don't want to use the table. When you're using the standard normal distribution, it's norm.s for standard.dist for distribution. You type in that z-value, comma true, and that then gives you the percentage of data that is to the left of that z-value or less than that z-value. Question 2 is similar to question 1, but instead of finding the percent of data that's less than a z-value, we're finding the percent of data greater than a specific z-value. And so what we have to do then is use some subtraction. So let's look at the z-value negative 1.50. I would go to negative 1.5. And that very first column is what I want because that's where the second decimal is a 0. So negative 1.50. I know that you can see up here from the description, this is the percentage of data that is to the left or less than the given z-value. So 0.0668 is less than our z-value. So I'm going to use a calculator and do 1. For 100% as a decimal is 1. 100% minus the percentage that is to the left or less than our z-value. And what you'll get for your answer is the percentage that has to be to the right. So if there's this percentage to the left, then there's 0.9332 to the right of our z-value. As a percentage, slide the decimal point 2 spots to the right, and you get 93.32% is greater than or to the right of the z-value. Using the formula in Excel, it's just like that table. It only gives less than percentages, probabilities of being to the left. And so again, once you get your answer, you have to do 1 minus that answer in order to get the percent of data that is greater than your given z-value. Number 3, now we're going to use the standard normal distribution table to find the percent of data in between two z-values. And let me do a brief illustration here to explain how we do this. A normal distribution looks like this. It's bell-shaped. It's highest in the middle. Most of the data is in the middle, right above the mean. And then it's symmetric. As you get larger than the mean, there's less and less data. And then, the height of this curve shows you how much data there is. So the further away you get from the mean, the amount of data is going down. And you get that same symmetry on the less than the mean side. Most of the data is by the mean, but the further away you get, the further you move this way, you can see the curves going down. There's less and less data. So the z-values we're looking at, the percentage of data that is to the left of a given z-value. So let's just say we have this z-value. I'm not going to put a number to it. For any z-value, you can find the percent of data that is to the left of that z-value in the table or using Excel. And that's what we did in question 1. So we would find the percent of data, all this data here, that is to the left of the z-value, table or Excel. Just look it up. To find the percent of data that's to the right of the z-value, like we did in question 2, when we use the table or Excel, it's given us this green part, so we would have to do 100%, because you can see 100% is colored in here, either red or green. So you do 100% and you subtract away the green part. When you subtract away the green part, you're left with the red part. So that's what we did in question 2, 100% minus what you get in the table or Excel, and you're left with the greater than probability. So how do you do question 3 and in between two probabilities? Let me get a black line here. So in this case, we would want just what's the probability of being in between two different z values. So I'll call this z1 and this one z2, just so you know they're two different z values. The probability of being in between those two. Well, if we look up anything in the table, and what we're going to do is we're going to look up this one that's further to the right, the larger z value. This one right here. We'll look that one up first. And what the answer we get back from the table or Excel will be all the data to the left of it, all the way down to the end of the distribution. So you can see the part we want to get rid of is the part right here in the tail. I'll color it in red. We want to get rid of that. Well, look at where that is. That is from the smaller of our two z values, everything less than or less than that. So we can look up our smaller one then and subtract it away from our answer that we got from the first one. And so if we subtract away that part in the tail, everything to the less than or left of that smaller one, all we're left with is what's in between our two z values. So we're going to look up the larger z value first, and we'll get the entire everything left in it. And then we're going to look up the smaller z value and subtract away that amount from our first result, and we'll be left with what's in between. So with the two z values in this problem, the larger one is 0.75, so I'm going to look that one up first. And there's my result, all the percent of the data that is to the left of the larger one. And then here's my smaller one, negative 0.55 is less than a positive 0.75. So this is my smaller one. I look up the data that is to the left of that, less than that, and I get that value. So I take my result from the larger one and subtract away the result from the smaller one, and all I'll be left with is the percent of data that is in between those two z values. So as a percentage, slide the decimal point 2 spots to the right, you get 48.22% in between. For number 4, we have a problem, and in this example, our vending machine is going to dispense a mean of 7.5 ounces of coffee. And it says the standard deviation of the amount dispensed is 0.3 ounces. So we have the mean and the standard deviation. And we're told that the amount distributed or dispensed is normally distributed. And so we want the percent of time that the machine will dispense less than a specific value. And so what we need to do is find the z value that relates to this number here. And then you can use the standard normal distribution, look up in the table that z value and find the percent of data that is less than the z value associated with your number. So how do you do a z value? You take your number, subtract the mean away. We're trying to see how far away it is from the mean. And then you divide by the standard deviation, which was 0.3 in this case. So here I have it typed into my calculator. I'm using Excel. 7.38 was my value. I'm subtracting away the mean to see how far away my value is from the mean, and then dividing by 0.03. Now I use parentheses. You have to make sure you divide that entire result by your standard deviation. So if you are trying to type it all in at once, make sure you're following the order of operations where you're taking that entire result and dividing by the standard deviation. If I would have left those parentheses off, it would have just divided that second number by 0.03 and you get a completely different solution. So you're taking the difference between your value and the mean, whatever answer that is, divided by the standard deviation. So this is my z value, my z score, it's sometimes called, for this data value, 7.38. I can look that up in the table, or I'm just going to use it right here in Excel. I'm looking up negative 0.4, and I want everything to the left of that, which remember that's what Excel does by default, so this is going to be my solution. as a percentage, that's 34.46%. And just to see it here in the table, so I want negative 0.4. So here's negative 0.4, and I don't want any other decimals after that. So I want my second decimal to be a 0. So I'm actually in this first column, 0.3446, which is what we have as the percentage. Number 5, we have another scenario where we have a normal distribution. We're told the mean of that distribution and the standard deviation. And then we're going to find what percentage of cars are traveling faster than a given value. So we need to transform this given value into a z-score, and then we can look up the percentage of cars. In the table, it'll give us the percentage of data that's to the left or less than. So if we want greater than or faster than a certain value, we'll have to use the 1 minus whatever answer we look up. So going to get a z-score, I'm going to take my value, subtract away the mean, and divide by the standard deviation. So how you get the z-score in words here, your data value minus the mean, that's what I have on top. My data value is 45. And the mean's actually 45 too. So I have 45 minus 45 on top, and then divide by the standard deviation, which was 6 miles per hour in my example. This answer comes out to 0. So what percentage of cars are traveling faster than 45 miles per hour? I need to know what percentage is larger than a z-score of 0. So norm.s.distribution of 0 for my z-score. And remember, this will give me the percentage of cars, the percentage of data less than my z-score. So I want to do 100% minus that answer. And that's the percentage larger or faster, in this case, than my value. So since we're right at the mean, if you think about how a normal distribution looks, it's perfectly symmetric on either side of the mean. So if there's 50% going slower than 45, slower than the mean, there should also be 50% of cars traveling faster at a larger speed than the mean. So 50% on each side of the mean, and 50% is our solution. For number 6, in this case, we're looking at annual daycare cost per child, and we're told it is normally distributed. We're told the mean, and we're told the standard deviation. And then the question is, what percentage of daycare costs are more than a specific amount? So we're going to need to translate this information into a z-score. So we're going to take our given data value, subtract away the mean, and divide by the standard deviation to get the z-score for our data value. So here we are, our data value minus the mean divided by the standard deviation. The z-score, it's negative, which should make sense because our data value is less than our mean. So what percentage of data, what percentage of daycare cost, it would mean in this scenario, are more than our data value? If we use the table or Excel, norm.s.distribution, and we type in our answer here for our z-score, and then we have to type in true in Excel. That answer we get back is the percentage of data that is less than this given z-score. So if this percentage is less than it, then 100% minus that, 1 minus that decimal, would be the percent of data that is greater than or larger than that given z-score. So as a percentage, slide it 2 spots to the right, that's 74.75% of data is larger than this data value. Or in terms of this problem, 74.75% of daycare costs are more than this annually. Looking this up in the table to do one last example of that, this was our z-score. And notice that the table, we had to round up to 2 decimal spots. So negative 0.67 we'd want. Negative 0.67 right here. So in the 7 column, negative 0.67, we would get 25.6 0.2514 is less than or to the left of our given z-value. So if you did 1 minus 0.2514, we get the percent of data that is to the right of our given z-value. Now notice it does look quite a bit different. If you write this as a percentage, it's 74.86%, and that's because we had to round in order to use this table. It's only accurate to 2 decimals, negative 0.67, where in Excel, when I did this formula, I just referenced that cell by using A2, so I didn't have to round at all, and Excel gave me a much more precise answer. Now don't worry, whichever method you prefer, StatCrunch will, MATHLAB will accept it here. And notice that it has 2 correct answers listed because it knows that students are approaching this in different methods. Some are using technology, like Excel. Others are using a table and looking up data. So as long as you're in the general ballpark of one of those 2 results, it will be counted correct here by my MATHLAB.